Alright, so we can't leave this like this. So when we multiply, we get 3 square root of 2 times the square root of 2. This is 3 times 2. Square root of 2 times the square root of 2 is 2. Negative 4 square root of 2 over 6. Now you could go a step farther and even simplify this. You could have done it here as well. The 4 and the 6 can be actually simplified to 2 over 3. Again, we could have done that back here and taken out this to a 2 and this to a 1. Either way you do that is all right by me. Alright, finally here you got your tangents. Or not finally, but next. Tangent of theta is going to be y over x. So you've got the negative square root of 2 over 4. Right, negative square root of 2 over 4. That's okay, we can leave that like that, nothing to simplify there. Cosecant theta. Alright, so cosecant theta, there's a couple ways you can do this. If you know what sine is and it's simplified, you can just flip sine into your value here, which is 1 over 3 flipped would be 3. If you did it the long way and you chose to put r over y, you would get 3 square root of 2 over the square root of 2, which you can see is just still 3, right? Alright, back to secant here, secant theta. Now on this one, I ended up with a square root in the bottom when I first put it here, so I'm going to go back to this cosine and I'm going to flip this one into the original. See, if I flip the end result, I know I'm going to have to do something with the square root again. So let's say we just do it right here with this first one, and we have a 3 square root of 2 over negative 4. You know that negative can go anywhere. It can go on the top or the bottom, just not both. It can go on the outside like this. Last but not least, cotangent. Cotangent of theta. And cotangent of theta is x over y from the left-hand side there. It's the reciprocal of tangent, so if you put x over y, it's negative 4 over the square root of 2. So again, multiply by the square root of 2, and you get negative 4 square root of 2 over 2, which is negative 2 square root of 2. Those guys are going to cancel out to 2. Alright. Let's head on to the back here. Number 3. It says find the exact values of the other 5 trig functions for the angle in standard position given the following. Okay, now this one's actually somewhat complicated. On number 3, it says sine of theta is negative 5 over 13. Negative 5 over 13. And then it gives us this guy. 3 pi over 2 is less than theta is less than 2 pi. Think about that for a second. Let me do this up here. Here's 3 pi over 2. And it says that theta is bigger than that and smaller than 2 pi. What that tells me is that this thing is in quadrant 4. So I'm going to draw a angle here. Quadrant 4. So here's my theta. And it gives me sine is negative 5 over 13. Negative 5 over 13. Now we know that sine is y over r, right? Where does that negative have to go then? Think about the position. Right now it's somewhat like this. So where would that negative have to go in order to end up in the 4th quadrant? It would have to go on your y, wouldn't it? Because r is always positive. R is always positive. It's a distance. So what you've got then is y is negative 5 and r is 13. Negative 5 13. You can use good old Pythagoras here. Figure out what x is. We'll say x squared plus negative 5 squared equals 13 squared. X squared, this is 25, this is 169. So if you subtract your 25 over, you get x squared is 144, which means that x is 12. So very quickly then, we've got sine. Let's do cosine of theta is x over r, 12 over 13. Sine was already given to us. We've got tangent of theta is y over x, negative 5 over 12. Cosecant theta is the reciprocal of sine. Secant theta is the reciprocal of cosine. Cotangent theta is the reciprocal, of tangent. Alright, so take a second, fill that out, pause if you need to. Finally here, secant of theta is negative 2. And then it gives you a bunch of mess over here with pi and 2 pi. Here's pi, here's 2 pi. Think about your quadrants. If you're between pi and 2 pi, pi, 2 pi, that means you're either in quadrant 3 or quadrant 4. Right? Quadrant 3 or quadrant 4. Now think about this. If secant is the reciprocal of cosine, so if cosine was 2, then secant would be 1/2. If cosine was negative 4, secant would be negative 1/4. If secant is the reciprocal of cosine, this is dealing with x values. Where is x negative? Well, x is negative between the second and the third quadrant. X is negative over here. Which one of those fit into my restriction? Only quadrant number 3. And if you'll remember, secant of theta is r over x. So this is negative 2 somehow. That means that I'm going to put this thing over 1 to make it a fraction, and this negative has to go somewhere. Right? This negative has got to go somewhere. Can it go with r, or does it have to go with x? That's what you should be asking yourself. R is a distance, so it's not going to be up here, but x values can be negative, and they are negative in the third quadrant, so that makes this thing 2, this thing negative 1. 1 to square root of 3 maybe? But it's not just any old square root of 3. What's your y value down in this third quadrant? It's also negative. Now you could have done that without the Pythagorean theorem. If you wanted to set it up, you still could. Plus y squared equals 2 squared, right? So you end up with y is the square root of 3, and you have to know to make it negative because it's in the third quadrant. Here's your theta. Alright, let's set this thing up. Alright, awesome. Setting this thing up, you have a, what do we need? We need a sine. Theta is y over r. Cosine of theta is x over r. Tan theta is y over x. Cosecant theta is going to be the reciprocal of this, so it's going to be negative 2 square root of 3. Negative 2 over the square root of 3. We know we can't leave it like that, so it's going to be negative, let me go over here. Negative 2 square root of 3 over 3. Secant, it already gave us, is -2, and cotangent is the -2 over the square root of 3. Whoa. Completely did tangent and cotangent wrong. Ha! That's the bad thing about having no one here to stop me doing this. Josh is here, but he didn't help. That's okay. Say hi, Josh. Hi, Josh is going to be on the homework now. Yay! Josh is here, but Josh didn't help. Tangent's y over x. What am I doing? It's the negative square root of 3 over 1. That makes this 1. -1 over, -1 over negative square root of 3. Good grief. That makes this a positive square root of 3 here. Knew something was funky there. These will go to positive, multiply by the square root of 3, multiply by the square root of 3, and you get square root of 3 over 3. Da, 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 da. Okay, those are your trig functions. Make sure that you pause the video at any time if you need to catch up, and see you in class. Yay!